Okay, let's get right into it. For the longest time, software was built as these huge single applications. We call them monoliths. Everything was in one big box. But the world has totally shifted to microservices, where we break those big apps into, well, dozens or even hundreds of tiny independent services. It's incredibly powerful for sure, but it also creates a brand new kind of chaos.
Here's a good way to think about it. A monolith? That's like a classic organized department store. Everything's under one roof, it's pretty simple to manage, and you know where to find things. But microservices, that's more like a sprawling, chaotic open-air market. You've got hundreds of different stalls, each doing their own thing. So, if you're a customer, or in our world, a client app, how on earth do you navigate all that complexity without getting totally lost?
So here's our game plan. We're going to start by digging into the core problem that microservices create. Then we'll introduce the API gateway as a solution. After that, we'll walk through 3 essential patterns that it uses to bring some order to that chaos. And finally, we'll zoom out and look at the bigger, more strategic role it plays.
All right, so let's start at the very beginning, the root of the problem. When you have all these different services, probably built by different teams, you also have hundreds of places where you need to handle fundamental jobs, like security or logging. And believe me, trying to build those things into every single service is an absolute nightmare. And what you're looking at here, these are what engineers call cross-cutting concerns. And the key thing to realize is that these jobs have nothing to do with what a service's actual business is. They're just foundational tasks that every service needs. But without a central place to handle them, every single team is forced to reinvent the wheel, becoming experts in authentication, rate limiting, caching. It's a huge waste of time, it leads to inconsistencies, and it just slows everybody down. And this is where the API gateway makes its grand entrance. It is a really elegant solution designed to fix this exact problem. Instead of having hundreds of different doors into that chaotic market, it gives you one single, well-managed front door for your entire system. So what is it really? Well, at its heart, an API gateway is what's known as a reverse proxy. It sits right at the edge of your system, and its job is to intercept every single request that comes in. You can think of it as the gatekeeper, the traffic cop, and the concierge, all rolled into one beautiful package that completely hides the messy back-end details from the outside world. But here is the most important part. This is its real strategic value. By creating this single front door, the gateway establishes a stable, reliable contract with the client. And what that means is your back-end teams can go wild. They can refactor services, combine them, even rewrite them from scratch. And as long as that gateway contract stays the same, the client application never has a clue anything changed. This decoupling is what gives you true agility. Okay, let's get practical. We're going to look at our first core pattern. This one is all about how the gateway solves the problem of chatty clients. Apps that have to make way too many little requests just to get a simple job done. So, picture this. You're building a mobile app, and to display a single product page, you need to pull data from a bunch of different microservices. User data, product info, inventory, reviews, maybe 5 of them. Now, you can't have the phone make 5 separate network calls over a potentially slow cellular connection. The user experience would be absolutely terrible. So, what do?
And bam, here's the solution, the aggregation pattern. It's a game changer. Instead of the client making all those separate calls, it makes just one single simple call to the API gateway. The gateway then does the hard work. It fans out and calls all the back-end services over the fast internal network, collects all the data, and then sends back one nice, tidy, complete response to the client. Problem solved.
But of course, this kind of power comes with some trade-offs. It's not a free lunch. Yes, your performance gets a massive boost, and the client code becomes way simpler, but now your gateway is more complex. It's also become a potential single point of failure, and if you're not careful, you can start cramming so much business logic into it that you accidentally create a brand new monolith, what we call the dreaded God Gateway anti-pattern. All right, next up is one of the gateway's most critical jobs, acting as the security guard for the entire system. This is the authentication pattern, and it is a big one. In a lot of modern systems, security is handled using something called a JSON Web Token, or JWT. Honestly, the best way to think of a JWT is just like a digital ID card. It's a small, self-contained piece of data that proves who you are and what you're allowed to access. You just present it with every request you make.
And this digital ID card? It's actually pretty simple. It's made of 3 parts separated by dots. First, you have the header, which is just some metadata, like how the token was signed. Second is the payload, and this is where the good stuff is, the claims, like your user ID, your roles, and when your access expires. And finally, and most importantly, you have the signature. This is the cryptographic proof that nobody has messed with the other two parts.
So, when a request carrying a JWT arrives at the gateway acts like a very strict bouncer. It runs a three-step check. First, it verifies the signature to make sure the token is legit and hasn't been tampered with. Second, it validates the claims, checking things like the expiration date. And third, it confirms the audience, making sure this ID was meant for this specific club or API. Only if all three checks passed does the request get in.
Now for our third and final pattern. This one turns our gateway into a traffic cop. The goal here is to protect our back-end services from getting totally overwhelmed, and we do that with the rate limiting pattern. And you know, rate limiting is about so much more than just preventing some kind of attack. It's a really strategic tool. You use it to boost your security against things like brute force password guessing. In the cloud world, it's absolutely essential for controlling costs, so a sudden traffic spike doesn't result in a massive bill. And you can even use it to enforce business rules, like creating free and paid tiers for your API.
Now, people often mix these two terms up, but there's a really important difference. Rate limiting is a hard wall. You get, say, 100 requests a minute. The moment you hit request 101, you get rejected. End of story. Throttling is different. It's more about smoothing things out. It handles bursts by maybe queuing or delaying extra requests, so the backend always gets a nice, steady flow of traffic.
And what's really fascinating here is how you choose which algorithm to use. It totally depends on what you're trying to protect. If your backend service can handle quick bursts of traffic, an algorithm like Token Bucket is great because it lets those bursts through, which is better for the user experience. But if you're protecting, say, an old, fragile database that can't handle spikes, you need something like Leaky Bucket, which smooths everything out into a constant, predictable stream. The algorithm has to match the system behind it.
Okay, we've looked at the individual patterns, so let's zoom out and put this all together. The API gateway isn't just a handful of useful tools. When you use it right, it becomes a strategic control plane for your entire system.
And here's why. Because every single request flows through the gateway, it is the absolute perfect place to implement what we call the 3 pillars of observability. It can generate detailed logs of every request, give you real-time metrics on traffic and errors, and kick off distributed traces to follow a request all the way through your system. It becomes your command center for understanding system health.
But we have to end this with a serious word of caution. The single biggest mistake people make is falling into the God gateway trap. If you start stuffing too much business logic and custom code into your gateway, it stops being a lean, efficient traffic cop, and it becomes a new monolith. It becomes the exact central bottleneck you were trying to get away from in the first place.
And really, this all boils down to one fundamental central tension that every organization has to figure out. By its very nature, an API gateway is a point of centralized control. But the whole reason we do microservices is to give teams decentralized autonomy so they can move fast. So how do you balance those two opposing forces?
And this brings us to the final, and I think most powerful idea. The way you design your API gateway isn't just a technical decision. It's a mirror. It's a direct reflection of your company's culture, its communication structure, and how it chooses to solve that deep, constant tension between central control and team freedom. Getting that balance right, that is the real key to building systems that can scale.